Hello, my name is Rich Howard, owner of Architectural Builders Supply, and this video is to go through the steps of setting up a Millermatic 141. If you're a welder, this video is not for you. There's nothing in this video that's going to be of benefit to you. I don't make a living as a welder, but it's a skill that I've developed to a reasonable extent because being able to weld serves what we do as commercial hollow metal door and frame distributors. Being able to weld frames, weld doors, make modifications in the shop are required. I found that it was really important to be able to personally weld. I took welding as a continuing education after I'd left college as an adult because my shop couldn't get the work out fast enough. And I realized the only way, since I didn't have the authority then to hire another welder, nor did we have space for a second welder, would be that I would learn how to weld. I would work before hours and after hours and on Saturdays as needed to pick up the extra slack. The class that I went to, I re-enrolled in Triton College, a community college, River Grove, Illinois, outside of Chicago. And we started with arc welding and stick welding and went to oxyacetylene welding. And that was really difficult because it's like playing the piano with the bass clef and the treble clef. You're thinking two different languages at the same time. Bringing the heat and bringing the flux. That was tough. But what happened was, after beating my head against it and staying with it, it clicked, and then I got good at it or reasonable at it. And at that point, I realized, oh, I'm good. And then we went to MIG welding, and that was easy by comparison. What makes it difficult for us is that we're welding very light gauge material, 16 gauge typically. But once I got that, I was ready to roll. And this video is to set up the tool because I need to use the welder for a job that we're doing. We've got a client who has a 4¼ inch thick wood door and needs a Yale 197 with a rim cylinder on the outside. The problem is the rim cylinder tailpiece or connecting bar. They don't make them long enough. Now I could hire someone to weld me the rim cylinder tailpiece. I'll just do it myself. I've got the welder, I've got the skill, the time, the desire, etc. And it's fun. Welding is art. So let's move on with setting up this machine. Owner's manual, we're definitely going to jump into that. Yeah, flux cord. That's what we're doing. We're doing flux core welding. What that means is I'm not going to have a tank of gas. That does, in my experience and what I've been told, and the opinion of people who do a lot more welding than I've ever done, give a cleaner weld. It's just for the work that we're doing, a flux core MIG wire is going to be perfect. Safety precautions, foreign language, definitions, specifications, selecting a location. We're going to need to start here with installation, then operation. Hopefully not any troubleshooting. So let's jump right to page 11. Rated welding output, amperage range, single phase. Okay, that's fine. We can't pull more than 20 amps to it. We're going to do flux core 30 thousandths, and I've got 30 thousandths flux core wire, 35 thousandths. Well, that's okay, but I thought I ordered 30 thousandths. The tip is what goes on the end of the lead, and I don't have the right tips for this gauge wire. I ordered 30 thousandths wire. They shipped me 35 thousandths. That's an issue. So I either get a new roll of wire or I get different tips. Let's move into the installation instructions just a little bit more. Installation. Let's do this, one step at a time.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
Here is our torch or our lead. I'm not going to need that hose. That strap I won't need. I won't need the regulator. The grounding clamp we're for sure going to need. This is going to be a wire gauge. I'll leave it in here for right now. So the regulator, the instructions for that, the strap, this would go around the cylinder, I'm quite sure is what this is intended for. A Velcro strap, we can put that to good use. This is a hose for the gas, we're not running gas. 35,000 wire we're going to need. And the grounding clamp cable must be already attached to the machine. Yeah, pretty. Look at that. Spin it around and take a look what's under the hood, obviously. Oh yeah. Yeah, easy peasy. Easy stuff. Okay. We're seeing how that's going to kind of go together. That's no problem. Cable. Stop. Protect your investment. Absolutely. There's our serial number right there. Material thickness. Well, that's nice. Boy, they didn't have these settings when I was learning how to do this, blowing through material. That's awfully nice. Wire speed. Grounding clamp. Line disconnect device too. Yeah, okay, sure. Your locate unit near correct input power supply. I've got that. Meaning proper circuit, proper valve. For 120 volts AC power, a 20 amp individual circuit protected by a time delay fuse or circuit breaker is required. Plug from the unit, and then your wall outlet. That's no problem. I'll have it. I've got my circuits here are 20 amps, at least 20 amps. Electrical profile. I'm not concerned with any of this. We're plugging in at 120 volts. Okay, installing the work clamp. That's number one. All of this is obviously put together. Tighten connection hardware with proper tools. Do not just hand tighten hardware. A loose electrical connection will cause poor weld performance and excessive heating of the work clamp. Yes, absolutely. It's the same as if there's a short in a line. Well, no. It's the same as if you have the conditions that will lead up to a short. If you don't have everything tightened together and complete and full contact between your metal pieces, the circuit is not really complete in the sense that electrons don't flow as freely as possible. So if I take this and I clamp this here just hand tight, it's going to wobble around. My electrons won't flow. It's going to cause the welder not to work right. Plus, think about sucking a milkshake through a tiny straw that's meant for a cocktail. If you really pull on that, you might get a little lightheaded. Same thing happening when you don't make proper full connections. You're trying to pull more through something than it's meant to, and something strains. And in electrical conditions, it will cause excessive heating. That can lead to a short. All right, so anyway, route work cable through hole and clamp handle. Secure cable with hardware as shown. Ah, okay, right here. All right, so I'm going to liberate the grounding clamp cable from the machine. And I know that I've mentioned it, but welding class, I graduated high school, went to college for a couple of years. I then joined the family business. Went back, I re-enrolled, well, I was already enrolled, in the community college. I went to a community college and then a four-year school. Frankly, I found the four-year school harder than the community college harder in terms of demands than the four-year school. Anyway, so I went back to that community school because they offered welding. And everything I know about welding was learned initially there, and then of course vaporizing metal. It's a very, very good life skill. Very good life skill. And on that wire diameter, I simply may have ordered the wrong wire diameter as well. I don't know what I did really, but we'll figure it out. Don't like that. It's fine. Fine the way it is. Okay, so we've got our work lead. Is it fine the way it is? The issue is I don't have a long enough socket to get in there. Maybe when I take a run down to Home Depot, I will figure out what socket needs so I can pull that cable out a little bit flatter. There's nothing wrong with the way that it is right now. I just don't want that loop around, so we'll see what we can come up with on that. Okay, so it's telling us to come, up through here and then to here. So putting it the way that it's shown in the instructions, it would be just like this. So they want this all the way down to the bare metal. Star washer comes off, washer comes off. We're going to flip that over. Okay, flat washer, star washer. It's a grounding clamp.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
Work clamp. We've got the work clamp installed. Generally, this would be hooked onto the rolling cart, but again, I can't find my rolling cart, so we'll just stick it there, get it out of the way. Work cable routing inside the unit. Yeah, your work lead. Your ground lead and your work lead. Okay. Long reach sockets. Work cable, output terminal block. Work cable. That's our work lead, our lead, our work lead, and our ground clamp. Our ground, I don't know that I'd call that a lead. I'd call it maybe a return. Okay. They're calling the ground clamp and its lead the work lead. That actually makes sense. So we've got the work lead routed. It came from the factory already bolted to the terminal block, output terminal block. Polarity. Okay. Really important on this page. Process polarity table. We're doing flux core. Flux cored welding. FCAW, right there. Polarity table, FCAW. Straight polarity. Connect to negative terminal. Cable to gun, cable to work. Connect to positive output terminal. So we've got two terminals here. There's one positive and one negative. So we've got to go positive to our output terminal. So our work lead, cable to gun. They're calling this gun. This is our work lead. So we've got to have a positive going here. And it's here, but I don't see where it's indicated on it what it is. Let's see if we can get some more light on it. I don't see it indicated, so that's okay. I'm not worried about that. We're going to need sockets, though, for sure. Yeah, our gun's going to come here. Okay. Negative. Flux core. I got to flip these, I think. From the block to the negative is the short wire. Yeah, I've got to flip them. This is wired from the factory for gas welding, not for flux core. So I've got to switch these around. The issue is, right now I need a socket set. I don't like intentionally using the wrong tools when I know that it's wrong to do that. So we're going to go forward a little bit. I'm going to see if there's any other piece parts tools that I might need. Okay, yeah, this is going to have to come off to run a smaller diameter. I don't have an 8-inch roll, 8-inch roll of wire here. And frankly, for the amount of welding I do, this is going to be a good long supply of it. So we'll have to pull that off. I'll need a wrench or a socket for that, not a problem. Pliers, 1/2-inch wrench. Threading the wire through, that's easy peasy. That's just setting it up. We're not doing gas. Removing MIG gun after replace with a spool gun. Yeah, we're not doing a spool gun. Spool guns are, they have a spool connected to the gun. Okay, so then we get into operation. Okay, we are back and we are going to figure out where we got held up. And we are reversed. Our polarity is reversed. Our work lead is how we like it. Awesome. Now, okay. Polarity, cable connection, cable to gun, cable to work, positive to output terminal, positive. We're doing flux core wire, so my work lead needs to be coming to positive. My work lead is coming to positive, so we're good. Okay. Righto, let's graduate to the next page. Installing welding or gun or spool gun. We got a welding gun. A spool gun is on top of this contraption. You're going to have actually a spool of wire. It's going to be the spool's not inside the unit at that point. Drive assembly. Okay. Gun trigger plug. Okay. That's here. Gun trigger receptacle, here. route gun trigger plug through front panel. I like to read the entire step before I do anything. Gun securing knob. Gun end. Loosen knob. Gun secure. There's only one thing here that's called the knob. That's number 4. So loosen that. Insert end of gun through opening in front panel until it bottoms against drive assembly. All right, they're referring to this, so let's cut this off. We're going to loosen and then insert. Let's get our tool again. Loosen knob. This is the knob. I'm going to loosen that. It's loose. Loose and not coming off. Knob. Insert end of gun through opening in front panel until it bottoms against drive assembly. All right. Let's put this on its side so we can better inspect what's happening. I don't know if I keep pushing it because it's got a rubber gasket there. I imagine I'm going to push it all the way through. Be sure that gun end is tight against drive assembly. Incorrect installation will have adverse effects on gas flow. Righto. 5, correct. Incorrect. Yeah, they're showing us push it all the way in. Right now I've got it like this, and that's not right. So let's push it all the way in.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
Giving it a little rotational twist gets it to come all the way in. Now I can tell I'm tight. It does not tell me to tighten that knob. Oh, tighten knob. Yeah, it sure does. Tighten knob and closed door, in fact, is what it says. I'm going to hold the gun lead tight this way. Put pressure on it and tighten that knob. All right. Okay, what's up next? Changing drive roll or wire inlet guide. Inlet wire guide is 1. That's the inlet wire guide right here. Right there. Remove guide by pressing on barbed area or cutting off one end near housing and pulling it out from the hole. Push new guide into hole from rear until it snaps in place. Well, we don't need to do that. This is a brand new tool. There's no reason to remove that. Changing drive roll or wire inlet guide. We're not... Okay, so we're fine. Drive roll. The drive roll I think we have to change or reset. The drive roll includes 3 different sized grooves. Aha. Yeah, so right. The perimeter of this is going to have 3 different groove sizes. All right. The text aligned with the drive roll retaining pin indicates the selective groove. See section 512. 512. So we need to be set up on the 35 thousandths V groove. Retaining pin. To secure drive roll, locate open slot and push drive roll completely over retaining pin, then rotate drive roll to desired slot. So let's see what we're doing here. So as far as I can tell, we're actually already set exactly how we need, because that pin is right on my 35 thousandths. So look at us. However, I'm not in love with that. I don't like how it doesn't appear as if the wire is right in that V spot. Spring loaded. All right, that's off. That's 24 thousandths, I think. And that's got me set all the way over here. Okay, so let's go to the next step, which I think is $35 thousandths groove, 35 thousandths V knurled groove. For flux wire, we want V knurled. For flux core wire, which is what we have, what we're going to use, we want to go one more. Yeah, yeah, makes sense. So our wire is going to ride in that V groove there, the V groove. Let's take it out and study it since there's really nothing to it. $24 thousandths on the left, 35 thousandths groove, 35 thousandths V knurled groove for flux core. Beautiful. So let's put that back in. Easy peasy. Probably go backwards with it. Yeah. Perfect. Okay, I like the orientation of that. Seems good. Seems real good. That is set the way we like it. Installing wire spool and adjusting hub tension. Installing a 4-inch wire spool. Well, that's what we have here. I'm pretty convinced it's a 4-inch wire spool. I didn't see any 8-inch wire spools or 10-pound rolls at Home Depot, but when you're doing production, you're welding all day, you're not going to run with these tiny rolls. Yeah, it's a 4-inch roll, so we're in good shape there. It's good to go through this step by step. All right, installing the 4-inch wire spool. So now, when a slight force is needed to turn spool, tension is set. All right, so we've got to remove that nut as best I can tell, and I think it said it was 1/2 inch. Yeah, sorry you didn't see that. That socket, I knew that was going to do us good as well. Let's see if we can get lucky with this one. Beautiful. This is the adapter for the 10-pound roll. I think that's loose. Yeah, the nut's in there. Okay, spring. Let's put that right there. Washer. Nut, spring, washer. There's my washer. There's my drive adapter. And I guess we're going to put that sucker right on here. That's what we're going to do. It's flux cord. All position single pass flux core welding wire designed to weld carbon steel. I should have gone through this earlier. We're welding carbon steel. Unique quality of this product is that you do not have to use shielding gas. So shielding gas, what's really interesting about that is when you are taking two pieces and you're welding them together, you're bringing the wire, you're bringing the heat, but what you need is an environment in which the heat and the wire can be brought to amalgamate with your base material. The gas that would normally be used or typically be used creates a bubble or a shield around the environment. That space within the shield or the bubble is what allows the welding to occur. Flux core wire does not achieve it in this way, and I'm not an expert, so I won't try to explain it.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
The E71T GS produces smooth arc action, low spatter, full slag coverage, and easy slag removal. The bead appearance is not equal to gas shielded product. That's for sure from what I've been told and what I've witnessed. Gas is going to give you a cleaner weld, but the benefits of not having to use gas makes this product extremely popular. This E71T GS, I didn't pick that alloy specifically, but I chose the flux core and the base material that I was welding, steel. This wire operates on DC straight polarity, DSEN. Make sure your power source is set properly for a good non-porous weld. That's going to be full of holes that you won't really have good welding at all. So I'm going to pull this off. Here's my wire. Let's put the washer, the spring, and the nut back on. And what it said was, when a slight force is needed to turn spool, tension is set. Don't go too far. There's a motor in here. The nut's on, and that's a slight force. It's not going to fall off. I like that. So this little deep reach socket set's proven to be pretty handy. We've used 5/16 here and then 1/2 inch for here. Now we're going to need to cut that wire, and we're going to feed that through here, and then we'll have to plug it in, and we'll hit the trigger and it will draw the wire out. So we are literally at that step. We're not doing the installing 8-inch spool wire. Same process. This is really important. We do not want to lose it, because sooner or later there's going to be an 8-inch roll on that. Now, threading welding wire. 1, wire spool. 2, welding wire. 3, inlet wire guide, that little plastic guy. 4, pressure adjustment knob. Drive roll. Gun conduit cable. Lay gun cable out straight. Okay, let's go over the parts. 1, our wire. 2, our spool. Our wire will come through. 3, the inlet guide. 4, pressure adjustment guide. Here. 5, drive roll. We've already inspected that. Gun conduit cable is here. Okay, so it says lay gun cable out straight. You don't want it kinked, because we're gonna plug this in and we're gonna feed that wire through. That's what we're gonna do. 1, open pressure assembly. Yeah, we've got the pressure assembly open. This is already opened. Yeah, okay, it's open. 2, hold wire tightly to keep it from unraveling. Pull and hold wire cutoff end. Got it. Push wire through guides into gun. Continue to hold the wire. Use pressure indicator to set a desired drive roll pressure. Begin with a setting of 2. If necessary, make adjustments. I'm just going to turn it to 2. I'm going to say that 2 is right in the center. Be sure that wire is seated in proper drive roll groove. Close and tighten pressure assembly and let wire go. Push through wire guides into gun. Continue to hold wire. Okay, so I'm going to cut it. I'm going to push it through here, get it into here, and I'm going to set that, this pressure assembly is what they're calling it. Got my left hand making sure the spool doesn't jump on me. That piece of wire that's left in there, I'm going to pull that out. I don't want it snagging anything that we're working on. So, good, push, push. We've hit the drive. Now we got to get it into the gun. Easier said than done. A little bit of a bend to the end of it to curl it up to help me get into the orifice on the gun lead. That might do it. Oh yeah. Yeah, now we're in. I don't know how far it wants me to go in. So, down, flip it up. Now we've got pressure. The instructions said, make sure your wire is in the groove. I'm going to hold my wire again. I'm going to pull that down. And it's in the groove. We're seated. I'm happy with that. Down and up. I don't know how that changed. I must have rotated it. Okay. All right. Pressure assembly is tightened and the wire has been let go. I've got it set to basically 2. Remove gun, nozzle, and contact tip. Okay. We're just following the instructions. Remove gun nozzle and contact tip. Well, I don't believe we have a contact tip installed. This is right out of the factory. Does it unthread? I believe it does. Nope, it just pulls off. There's no contact tip installed, so we're pulling our nozzle off. Put that right there. 6, turn power on. That means we're obviously plugged in. 7, press trigger until wire comes out of gun. Keep gun cable as straight as possible. Unit will enter jog mode after trigger is held for 3 seconds. Be sure that tip matches wire diameter. Again, the orifice on this needs to match the diameter of the wire. According to the labeling, we're correct. Feed wire to check drive roll pressure. Tighten knob enough to prevent slipping. Cut off wire, close door. So what happens, what that means is the pressure that's here, when you hit the trigger on the gun, what's most crucial is that you get constant feed without it slipping. You don't want it harder, you don't want more pressure than necessary, because then the motor that's obviously on the other side of this is working harder, but that's the next thing here. So before we move on, there's a nice little cheat sheet up here. You can weld stainless. You just need the right wire for that. If you're going to weld aluminum, you're going to need gas. I've never tried to weld aluminum. I'm going to someday for sure. Flux core. No shielding gas required. Good for windy or outdoor applications. Yeah, that's the case because you're not creating a shield like my bubble. All right, these are feed suggestions. Manual setup. Refer to chart at right to select voltage and wire speed based on thickness of metal being welded. Number on right of slash is wire speed. So I'm at 35 thousandths. Today I'm going to weld something thicker than 16 gauge. I'm really going to be about 14 gauge would be my guess. So 55, what is that, inches per minute maybe? And then select on left of slash is voltage set knob setting. So speed rate, wire speed, and voltage. Yeah, what did it give me? $540, 1055. Well, you play with that and you'll figure it out. 1/8 inch, yeah, somewhere between 5 and 10 for voltage. So I'm going to be right at about 7.5. Our wire speed will be here. I'm just putting that there just because I wanted to show this. What's also nice here is the changing of the polarity.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
We've got the wire fed through. We're seated. The nozzle is removed. It says turn power on. Press the trigger. It'll go into jog mode if you hold it for more than 3 seconds. Wire comes through. Tip goes on. Nozzle goes on. Wood. Feed wire to check drive roll pressure. Tighten knob enough to prevent slipping. Cut off wire. Close door. I've not seen any instructions as to when we're supposed to connect this. But it's clearly shown here. It's shown here. It's shown here. Where did I miss it? Here, 2. Gun trigger plug. Right here. Step 5.9. I clearly missed it. Route gun trigger plug through front panel. Insert plug into receptacle and tighten threaded collar. Okay, so I missed that part. Route it through. Bring it in. Okay, there's only one way for it to go on. You can see the notches cut in here. You can see the end of the plug. Okay, I'm pushing it with my right hand and I'm turning it with my left. It's now tight. Okay. Next, plug it in, obviously. There's no switch on the door. I'm going to leave the door open because I want to watch what's happening here. Next thing to do is to plug it in. And I did say earlier that I've got a 20 amp circuit, and I fully believe that it is. I'm going to find out. I don't see how it would be less, quite frankly. This is a commercial space. Okay, we're plugged in. Turn power on, which is back here. That's gas. That's open. There should be nothing left to do at this point. Turn power on. Press gun trigger until wire comes out. So our gun lead is here. It doesn't have to be straight. It just can't be kinked. So right here is going to be good enough. We get over here and we should see our wire start to move. Yeah, there it goes. Slowly coming out. Now it goes into jog mode, as I said earlier. We're watching for it to peak out here and then I'll let go. We're clearly feeding. I can see that we're feeding into the V groove really nicely. I don't feel any slipping at all. I'm just going to leave it on 2. Let's just keep going. Wire's feeding, good. I don't know the rate of jog mode. We've got it just laying here on the ground. No big deal. That wire's going somewhere, so it's got to be coming through. There it is. Wire came through. Nice and slow, nice and slow. Beautiful. Okay, I love that. Unit will enter jog mode after 3 seconds. We will witness that. Be sure that tip matches wire diameter. Reinstall contact tip and nozzle. Now we're about to make sure that this is the right size. Just going to rest that on the tool. I'm going to go get my utility blade. I'd always use the Miller 135s. I'm sure I've mentioned that 100 times. Why I bought a 141 is probably because the 135 was discontinued, would be my guess. Obviously it has to go in backwards first. It fits in, that's good. It threads on, that's good. Just hand tight. Nozzle, again, is going to pressure fit on. Perfect. I gave it a little bit of a turn and it slid on. Let's take this here piece of steel. Let's put our grounding clamp on it. And if I don't get a good arc struck here, then I'm just really going to want to clean that. I'm going to hold my hand over my eyes. Boom. There you go. This welder works. This welder works. It works well. All right, let's turn it off. Now, normally what would happen is you would clean the surface of your steel because the impurities on top of the steel are going to be an impediment to a circuit. So this circle is the symbol for an open circuit. That straight line is the symbol for a closed circuit. Right now, the machine is on. Let's just imagine the machine is on and running. Right now, I have an open circuit. When I hit the trigger, it's going to force the magic that is welding to create a closed surface as soon as I make contact with my wire, the base material, and the grounding clamp. So the wire to the base material through the grounding clamp, through the machine, is what creates the closed circuit, and that's how welding occurs. It's really awesome. All right, let's take a look at what's next, except I don't think there's anything left except to weld my pieces together. The welder works. That's great success. At this point, I can close the door. Nothing else happening. And in fact, there's really nothing else that you need to do until it's time to change the tip, to change the nozzle, to change the spool of wire. If you're going to be welding, if you're going to be actually welding, you are absolutely going to want to have an extra spool of wire. Buy the big wire, buy the big rolls. If you're going to weld, always keep that small roll. You know, I'm going to get a larger roll and put it in the machine at some point, but that small roll will be kept. I'm okay with the tension. It seemed to work fine. I put it on the factory prescribed setting. Oh, and that seemed to work as well. I will go through the process of optimizing this at some point, but that point is not right now. Installing gas supply, we're not doing that. Removing MIG gun after installation to replace with a spool gun. We're not doing that. We're not running a spool gun. Operation. Auto set material thickness. That's nice. 16 gauge is most common for hollow metal shops, obviously. Wire speed, you've got the cheat sheet that's inside the unit, meaning underneath the lid. Voltage, material, thickness control. Turn control clockwise inside white scale 1 through 10 to increase voltage. See weld parameter chart in welding power source of section 6.4. The bottom line is you got to have enough voltage, enough oomph, enough chutzpah to make that work. Thicker material is going to require the flow of more electrons, so you're going to need to increase the voltage. Wire speed. How quickly that wire's hitting it is obviously balanced with all of this. Turn control clockwise inside white scale 10 to 100 to increase wire feed speed. See weld parameter chart in welding power source. Again, that's here. I would have to say there's a lot of years of evolution here. I would start here and then, yes, optimize. Optimizing is a concept that I learned through CNC, meaning you take your feeds and speeds, how fast you're moving, first of all, what you're cutting, the speed at which you're cutting, the RPM of the spindle, the diameter of the bit. All of that conspires to give you some feeds and speeds. These are the feeds and speeds that Miller has come up with. And there's a lot of welders out there. I've just always used Miller, and I think that's because there was a welding shop on Western Avenue in Chicago where I bought my first welder. You would literally walk in, it's a full-fledged welding shop. That's all I did. And these guys were experts. And I bought a Miller 135, and I have owned several and many Miller welders. I've never owned a Lincoln. I've never owned another manufacturer. I can't say that there's anything intentional other than Miller works for me, and I've never seen a reason to change. I don't spend all day welding either, so I'm not an expert, even though I can weld. Wire speed, that's part of optimizing. Over temperature light, if unit overheats, light turns on and output stops. Allow unit to cool. Resuming operation. We're very familiar with our GoPro. Overheating. This light will also communicate additional input errors. Section 7.4 power switch. Right here. We talked about that. Using auto set. To turn auto set on, turn the wire speed, wire diameter control knob to the desired wire diameter setting. I'm good. I'm not going to go with auto set. Jog mode, if gun trigger is held for longer than 3 seconds without initiating a weld arc, unit will enter jog mode. Aha. So as you saw, when I fed the wire, after 3 seconds it started to move quicker. That's not going to happen when you're actually welding, obviously. What's going to control that is your wire speed. You want it to go faster? Go faster. You need it to slow down for whatever you're accomplishing with your weld, slow it down. Optimizing it. Go 10% heavier, see how your results change. Go 10% lighter than your baseline, see how your results change. Continue to go half the distance until you're really happy.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
Okay, we talked about jog mode, weld parameter chart, weld parameters, troubleshooting guide. I don't think we have a need to go into it because our wiring diagram, I will likely never refer to this. I suppose I could. Yeah, okay. So, assuming this isn't your first time welding, you may not need to get into this. But if it is your first time, MIG welding guidelines. Okay, so here's what it looks like when you've got a tank. Yeah. I suppose if I did enough. The issue is you got to buy wire, then you got to make sure your tank is filled, blah, blah, blah. Nothing we weld is that critical. So we're not doing the shielded wire process. Welding wire is energized when gun trigger is pressed. Before lowering helmet and pressing trigger, be sure wire is no more than 1/2 of an inch past the end of the nozzle. 1/2 of an inch. So right now I'm a little far out. The bottom line is, if it's too far out, then you're really just spitting. You're spitting metal everywhere. You're spitting metal like I did here because I had so much wire. You can do that and burn the wire down. You can do that and burn the wire down. The problem is you're going to foul up your tip prematurely. So you really want to make sure you've only got you've got the prescribed amount of wire hanging out. Yeah, I'll nip that before I actually start to weld. So 1/2 of an inch past the end of the nozzle, and tip of wire is positioned correctly on seam. So in this example, they're showing you that you're going to weld 2 pieces of steel together. So right here. This is what it looks like if you're looking at the end of the piece. So end of the piece is this, if this is my piece. But what your gun's going to look like is on this angle here. From this perspective, it looks straight on. But from this perspective, you're angled. And yeah, you're going to be angling it, angling it. 0 to 15 degree, depending on what you're doing. You know, the angle is going to be dictated by what you're welding. Conditions that affect bead shape. Very good. You're pushing it versus dragging it. Gun angles and weld bead profiles. Short, normal, long. Short, normal, long. Yeah. What you're seeing here in the push method, when you're welding from right to left, let's say, weld, you're going to look a little bit flatter like this. When you're dragging it, apparently your bead's going to be a little bit higher and perpendicular. If I'm moving in this direction, I'm pushing. If I'm moving in this direction, I'm pulling. If I'm doing this, I'm perpendicular. You're just going to experiment. The way to get good at this is to weld. Right. Gun movement during welding. Normally, a single stringer bead is satisfactory for most narrow groove weld joints. However, for wide groove weld joints or bridging across gaps, a weave bead or multiple stringer beads works better. So what that means is rarely ever have I just welded like this, but sometimes. More often, it's this. I was also taught this. Okay, that's what I was also taught. This, never. This, sure. This, absolutely. Welding is how you're going to get good at that. We use weave patterns to cover a wide area in one pass of the electrode. Poor weld bead characteristics, yeah, all that splatter. Rough, uneven bead, yeah. Practice will get you good at that. Slight crater during welding. Yeah, craters during welding is just more work. Bad overlap and poor penetration. Okay. Good weld bead characteristics. Good penetration, really good. Your weld is even on the top. No overlap. That's this or this. Fine splatter. There will be a small amount. Uniform bead, yeah, take your time, make it look nice. Moderate crater during welding, there won't be much. You're going to heat that up and liquefy that as you're bringing in the wire, but nonetheless. Excessive splatter. This is troubleshooting. I'm not worried about that yet. Porosity is a bad thing. That is going to, it says here, gas pockets. It's just optimizing. If you're getting porosity pockets, you're going to have to tweak it according to this stuff. Excessive penetration, probably too much heat, too much voltage. Move faster. If you're really burning through it, you're going too slow, or you got too much voltage hitting it. Lack of penetration, you're moving too quickly. You don't have enough voltage, most definitely. Yeah, you know, incomplete fusion, you need to be able to get in there and liquefy these areas here to get that metal, all three pieces, 1, 2, and your wire to fuse. Burning through, way too much heat, way too slow. Keep moving, keep moving. Waviness of B, that's all in the hand. You'll learn that as time goes on. And distortion, heat. You're warping the metal. Excessive heat input. Awesome. Okay, so we're going to put the, and there's more. Okay, we're going to put this away, or at least in my box. The next thing to do is to turn it on and strike an arc. I believe the term is break a leg. Not awful. I'll inspect that a little bit more closely. Turn down my voltage to 6. I think we're a little hot. I feel like we've got plenty of weld on there, so I'm going to loosen the top and bottom, and that'll slide out. I'm going to inspect this.
Again, thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.